All right, folks. So now, once you've got a machine, you can start practicing basic techniques. There's four basic ways to analyze malware. There is static and dynamic analysis, and they come in basic and advanced versions. Basic static analysis is where you don't run the malware and you don't read the assembly code, and you try to figure out something about the malware anyway. So that's using techniques like strings and virus total and looking at the metadata in the portable executable header. Advanced static analysis is where you open it in something like IDAPRO or GIDRA and see the assembly code and read that to figure out what's going on, and that is the most difficult technique. Dynamic analysis is where you run the malware, deliberately infecting a machine, and watch what it does, which is fun and easy, although dangerous, which is why you should be working in virtual machines far away from anything you love. And simple dynamic analysis is where you just watch using tools that monitor what it does to the operating system, like Wireshark and Process Monitor and Process Explorer. And advanced dynamic analysis is where you open it in a debugger, and now you can run it and add breakpoints and change variables as it runs to see what it does in more detail. So what I'm going to start with is the basic static analysis. And so here's my Windows machine. And one of the places to start is with PEview. You can just download and put this on the machine. These are all free tools. And so if I run this, it gives me a look inside malware, inside any kind of file I want. And so if I look at one of the malware samples that you can get, this is Windows executable code. All Windows files start with MZ, all Windows executables. Then they have that this program cannot be run in DOS mode. These are all portable executable files with PE here. That's the format. And you have various sections. This has a text, RData, and data section, which is about the minimum you'll ever see. Everything in Microsoft is always named the opposite of what it is. That's how you remember it. So text does not contain readable text. It contains gibberish, which is assembly code. These are raw assembly code commands. The actual readable text you'll find in the data or the RData. See, here's where you have the import table showing the Windows API calls that it imports, like close handle and unmap view of file. And here's data, which includes the names of some DILs and such. All right, so this is one way to just get an overview of the file. And by the way, you can see some readable messages here, warning this will destroy your machine. And if you look closely, you can even spot some obvious indicators of compromise here. And I should mention, the point of malware analysis is not to understand 100% of everything the malware does. That's usually too much work. What you usually want to do is answer some specific questions like, what damage did it do? And how do I undo that damage? How does it spread? And how do I detect if other machines have been infected? So what you're looking for is the important changes it makes on the machine and indicators of compromise, which will be an easy way to find what it did to other machines, like network traffic it produces, or registry keys, or files it creates, or mutants it might create, which are handles in the memory. And if you notice here, this is C Windows System 32 kern E132.dil. And this is kernel 32. So this is obviously going to be an indicator of compromise. This is a fake file, kern E132.dil, that looks like a Windows system file, but it's spelled wrong. And that's obviously attempting to hide it from casual analysis. So this strongly suggests that I will find that strange file on infected machines, and right there, that's likely to be an indicator of compromise. So that's useful stuff just from looking at it in PEview. Another thing people often do here is they look at the, I think it's here, yeah, signature, file header. They look at this creation date. If you look at attributions from, say, Kaspersky and other companies, they will say this appears to be made by the Equation Group, which is the NSA. This appears to be made by other people. One thing they do is look at the date stamp, and you can see what time of day it was in various nations when this was created. And if it's made by some professional organization, it's probably made between 9 and 5 local time. So you can guess what country it's in from that. And also, if you have several different files, you can look at the creation time, and if they were all compiled at the same time, then they're probably from part of the same attack and not independent infections that might be floating around. So that's something people look at quite a bit there. Let me go back to my instructions here. All right, then there's PEID, another simple program. The point of PEID will show you what language the file is written in. So when you open it, it will just tell you this is Visual C++ or something like that, and that's useful. Then you have Bintext, which is extremely handy. In the world of Microsoft, we used to use this Linux tool called strings all the time. And strings just looks for series of bytes that are ASCII characters. And if they're longer than, say, 4 or 5 characters, it prints it out. So it's an easy way to get a quick clue of what's going on in a file. But in Windows, most strings are Unicode. And they're a particular old-fashioned kind of Unicode that uses just 16-bit characters. So it's handy to have a good tool to do that. And Bintext is a McAfee tool that is really very nice. It lets the Windows users feel a lot happier because they get a graphical environment. They don't have to go to the command line. So if you run Bintext, I can now open a file in here. And if I go to my desktop, malware, labs, binary, chapter 1, and I open this exe we were looking at before and go, then I can see all the readable strings in this file. And I wonder if I can make this bigger. I think I might be able to. I can't find any options to adjust. It's too bad. I thought it might be some way to make it bigger, but I can't find it. Anyway, you can see these files. Here's the C window kernel 32. This will destroy your machine. And you know, this doesn't prove what the functionality is, but it's really fast and easy, and it should be one of the first steps you use analyzing malware. By the way, the people using the Flare VM, you can download, you can do these normal cloud projects on that also. You're not restricted to just the Flare VM. These projects require the Flare VM, but you can do all of these on there also. So don't necessarily skip over them. All right, and then there's, that's PEID. All right, so if you go and look at another one of these at PEID, you're going to find that it cannot tell what language it was written in. And that is the indication of a packed file. It is very, see, this strings analysis is so powerful that malware authors would like to prevent you from reading the strings. And one way to do that is to pack the file. Now, the simplest packing we're all used to is self-extracting zip files, where it's zipped, and when you run it, it will unzip. And that's fine, but there are special packers just for executables, which conceal it in different ways to make it harder to see the strings. So this sample here is packed with UPX. And when you run it in PEID, it will not be able to detect what language it's in, but the UPX packer names the sections that would have been named text, data, and R data. It names them UPX0, UPX1, UPX2. So that's a clue that it's the well-known UPX packer. And if you look at it in PEView, you can see the sections here with this name. So you can, if you just normally packed with plain vanilla UPX, you can unpack it with UPX, which is a free download, just a command line tool, and you can extract the file. And after you extract it, it will of course get bigger, and it will, it goes from 3K to 16K, and the strings will all be readable now. So when you unpack it, now it's packed with Visual C++, and you can examine it. So now you can use Dependency Walker to see what libraries and what functions are used. This is still not the same as really looking at the raw assembly code where you see everything. Something's down?
Yeah, the repositories to download Flare VM.
Oh, well, oh, that's unfortunate. Okay, well, anyway, you can't do that during this workshop anyway, but hopefully they'll get it back up. That's rude. Anyway, so it shows you what libraries this file uses, and if you click on one of the libraries, it will show you which particular functions it uses, but you cannot see the arguments it sends you. So here you can see it's using Internet Open URL and Internet Open A, so that tells you that this file is connecting to some kind of internet server, so it's probably a bot calling home, and that's a good clue, but you can't find the exact URL it goes to from this tool. Because the purpose of this tool is not to show you the full functionality of the file, it's just to find out if you have dependency problems to help track them down. And so here's strings, and you see if you run strings on the same file, you will see these Windows API calls, and that suggests, of course, that it is doing an internet call, and now you even see a URL, but you haven't really proven that. For all you know, these strings are just random strings or strings that somebody put in a message and not actually code that runs. So anyway, that's simple unpacking and simple static techniques. Let me see if I've got anything else I want to mention here. Now you look through here, you find things like IP addresses, and I think that's enough there. So that's the elementary stuff. Let me stop this video and post.